Okay, so review problems. First and foremost, go over your quiz. Second derivative test, graphing, rules and mean value, and optimization. Those are the 4 topics that were not included on your quiz. So problems are given for each of those topics. We'll go over that in class specifically. Any additional practice you're looking for, they're listed there. And then right now, I'll provide solutions for 4 of the optimization problems that were assigned in class. Find the point on the function y equals x squared closest to the given point 2, 1/2. Now mod 1, I know you had a different distance function to optimize, but work on this one, because if you were given one on the quiz, or test rather, it would be more like this problem than the one number 14, which was assigned for you in class. Alright, so I know there were questions, primary versus secondary equation. Primary equation is what we're looking to optimize. We're looking to optimize the distance here. Now the distance formula here is in terms of 2 variables, so we do need a secondary equation. The secondary equation is the given equation. It's already solved in terms of x, so into our primary we'll replace y with x squared. Now, a lot of you had asked, and I think I touched on it for the most part. The distance is the smallest when the number inside the radical is the smallest. So we don't need to concern ourselves with the square root for the minimizing. So what's the distance? X minus 2, which is the x coordinate given, plus, using our secondary equation, y is equal to x squared minus 1/2, quantity squared. Now from here, you can expand the binomial, or you can just take the derivative as is. So using power rule, and then chain, derivative of the inside is 1, plus 2 x squared minus 1/2, times the derivative of the inside here is 2x. Now at this point, I did distribute. 2 times 2 gives me 4x. Distribute a 4x in here. I get 4x cubed minus 2x. Now this is already your derivative. So where does the derivative equal 0? When 4x cubed minus 4 equals 0. Solving that, we get x equals 1. The derivative exists everywhere. So you have to verify that this is, in fact, a minimum. This is where the second derivative test can be used. Look at how simple the first derivative is. So finding the second derivative, 12x squared. When we plug 1 into the second derivative, it gives us a positive value. Therefore, a minimum occurs at x is equal to 1. And we're looking for the closest distance, so we're looking to minimize. Now that we find x is equal to 1, go back into the secondary, replace the value we found. So to answer the question, find the point on the function. 1, 1 is the point on the graph of y is equal to x squared. That would be closest to the point 2, 1/2. A rectangular page is to contain 36 square inches of print. The margins on each side are 1.5 inches. Find the dimensions of the page such that the least amount of paper is used. Alright, a picture here is helpful. There's 2 different ways you could set up this equation, but I'll use the one that's the easiest math involved. Rectangular page, and we're told that 36 square inches of print. So that's always the secondary. The number is always the secondary equation. Okay, so imagine here are our margins. I'll just draw them in. So a rectangular page can include 36 square inches of print. So what are we looking to minimize? The dimensions of the page. Well, the dimensions of the page would be x plus 3, all right, taking into account the 1.5 margins on each side, by y plus 3. So that's what we're looking to minimize. Using the secondary, solving for y. Now plugging the secondary into the primary equation. You can use product rule to derive this, but I think taking a couple minutes and multiplying the polynomials. X times 36 over x gives us 36. 108 over x plus 9. Now when we go to find the derivative, 3 minus 108 over x squared. So I've been saying it all week, but we've already developed the tools to actually find the derivative. Alright, so rewriting that as 108 x to the negative 1 and then applying the power rule. So this equals 0 when x equals plus or minus 6. Derivative doesn't exist when x equals 0. Now this is where the feasible region comes into play. We're talking about dimensions of a page. So we know the dimensions can't be less than 0. So 6 is our only critical number. Now again, this is the first derivative test. According to the first derivative test, if I plug 1 into the derivative, I get a negative value. A number bigger than 6 would give me a positive value. Therefore, a minimum would occur at 6. The second derivative test, m double prime, would be 216 over x cubed, again using the power rule, rewriting 108 over x squared as 108 x to the negative 2. The second derivative at 6 is going to be positive, therefore minimum occurs at x is equal to 6. You just have to choose one or the other. Alright, you just have to verify that it's the max or min somehow. Alright, so take x, plug it back into the secondary, so we get y is equal to 6 as well. Squares always maximize or minimize. But now we have to go back, look at our primary equation. The dimensions were x plus 3, y plus 3. So to answer the question, what are the dimensions of the page? A 9 by 9 page the least amount of paper would be used if the paper was 9 inches by 9 inches. So that would be the final answer. What I'll be looking for on a test is that you verify the max or min using either the first or second derivative, and then of course that the question is being answered. A farmer plans to fence a rectangular pasture adjacent to a river. The pasture must contain 245,000 square meters in order to provide enough grass for the herd. What dimensions will require the least amount of fencing if no fencing is needed along the river? Least is a minimum. The number gives me my secondary equation. Now, a picture was provided in the text, but if you don't have a picture, pasture must contain square meters. Well, that's area. So our secondary equation, all right, it's along a river, x times y. So the area is 245,000 square meters. And we're looking to minimize the amount of fencing. Well, what's the fencing around? That would be the perimeter. And it's not 2x plus 2y. We were told there's no fencing needed along the river. Solving the secondary for one of the variables. Finding the derivative. Where does the derivative equal 0? And 2x squared. So I'm setting the derivative equal to 0, adding the term and multiplying by x squared on both sides. And then for this one, I encouraged you to use a calculator. You got plus or minus 350. Again, the negative answer doesn't make sense for the problem because we're talking dimensions. So I'm going to use the second derivative test. Second derivative here will give me 490,000 over x cubed. Second derivative at any value any positive value will be positive. Therefore, minimum occurs at x is equal to 350. Take this number, plug it back into the secondary. Y is equal to 700. So what dimensions require the least amount of fencing? A fence that's 350 by 700. So that would be our final answer. Found the derivative, critical numbers, verified the max or min, answered the question. A rancher has 400 feet of fencing with which to enclose 2 adjacent rectangular corrals. What dimension should be used so that the enclosed area will be a maximum? 400 feet. Again, let your units guide you. Picture was provided, but 2 adjacent rectangular corrals. So the deal with this, you just had to see that there was a third dimension for y. Area will be a maximum. So there's 2 rectangular pens that we are enclosing. So 2xy is the area that we're looking to maximize. 400 feet of fencing, that would be the value for the perimeter. 4x plus 3y equals 400. Solving the secondary for one of the variables, and I found it useful to just divide each piece, making the substitution, and now distributing 2y inside. Finding the derivative. Setting the derivative to 0. I know it doesn't seem like a usable number, but it is a number nonetheless. So 200 thirds. Now finding the second derivative, very simple second derivative. The second derivative at any value is negative. Therefore, the maximum occurs at the given critical number. Go back to the secondary equation. So we get negative 50 plus 100. So x is 50. What dimensions of 50 foot by 200 thirds foot fence? Now, some of you went to the primary and told me 100 feet. We're only looking for the dimension of x and y. So the value that we found for x was 50. The value we found for y was 200 thirds. Don't double it just because there's 2 pens here. Derivative, critical numbers. Verified the max or min, found the other dimension, or found the other value, and answered the question. Alright, so again, we will touch on each of these in class. In addition to this, you had homework assigned, and that was mean value and roles practice. And I asked you to complete one of the graphs that were distributed in class, 63 or 64. Mod 1 for tomorrow, Monday. Mods 2 and 7, I'll see you on Tuesday. I will be in lunch tomorrow, Monday, if you want to stop by for additional help. Enjoy the rest of your day.